Right, hello Year 11. So I'm going to go through this paper 1 paper from June 2014. I'd recommend getting it off the website first and having a go through it. Good. Right, so question 1, a straight line has a gradient -2 and passes through the point -310, and we want to work out the equation of the line. So first of all, we know m is -2, so we can say y equals -2x plus c, and then we can sub in these x and y values to find out c. So 10 is going to equal -2 times -3 plus c. So 10 equals 6 plus c. So c is going to be 4. So we can say y equals -2x plus 4. Good, let's just double check the mark scheme. So, good, 1 mark for kind of doing both parts. 1 mark for y equals -2x plus c, or c equals 4, and then 2 marks for both. Right, so question 2. Y equals 4x cubed minus 7x, and we want dy by dx. So hopefully we're just using the standard derivative rules here, so timesing by the old power and taking 1 away from it. So 4 times 3 is 12, so we've got 12x squared, and then minus 7x is just going to become -7, and I imagine you'll get a mark for each term there. Yeah, so 1 for each term. Okay, so next we've got some matrices. So transformation is given by the matrix M, where M equals 1a, 0, 2, and the image of the point B5 under M is 5b, and we want to work out A and B. So the first thing you need to do is set up an equation. So if you think what it's saying starting with this matrix, and it's saying the image of this point, so once we times this matrix by B5, by our matrix M, we should get 5b. So generally now what we're going to do is, well, let's see what we get when we times this out, and that's going to give us 2 simultaneous equations. So 1 times b is b, plus a times 5 is 5a, and that's going to give us 5. And then the next entry would be 0 times b, so nothing, plus 2 times 5, which is 10, equals b. So we've got that b equals 10 straight away, so we've already got the value of b, and then we can sub that into the first one to find a. So 10 plus 5a equals 5, so 5a equals -5, so a is -1. Okay, so there you get 1 mark for setting up this equation, or you can see they've times it together and given a kind of vector. Another mark for getting these 2 kind of simultaneous equations, and then a mark for solving them. Okay, right, question 4, so we've got to solve an inequality. So it's just a linear one, so it's not so scary. So the first thing we can do is expand out the right hand side, so we get 3w plus 6, and then we just need to solve it kind of how we do a normal linear equation. Just make sure if you divide or times by a negative, you swap the sign. So we'd have 2w is greater than 14, so w is greater than 7 as a final answer. So kind of 1 mark for expanding the brackets, that's not so bad. A mark for doing kind of 20 minus 6, and then a mark for w is greater than 7. Okay. Right, question 5. So they've given us 2 functions, f of x is 10 minus x squared, and g of x is x plus 2a times x plus 3. Circle the correct value of f of -4, so that's subbing in -4 into f. So we'll be doing 10 minus -4 squared, so that'll be 10 minus 16, which is -6. Right, then work out the range of f of x. So I'd highly recommend doing this by thinking about what a sketch of 10 minus x squared would look like. So hopefully you can see it's going to be a quadratic flipped over, and it's going to cross at 10. So we know it's defined for all values of x, so we're allowed to sub in any x value into this, and we can see it's always going to be below or equal to 10. So the range of f of x, so f of x is always less than or equal to 10. So you're thinking about what y values can it take for any value of x. Right, 5c, they've told us g of 0 is 24 and we want to show that a equals 4. So they're saying when we sub 0 into it, we should get an answer of 24. So 0 plus 2a times by 0 plus 3 has to equal 24. So in other words, this is just going to be 2a times by 3, which is 6a, equals 24. So we get a equals 4. Right, good. So there, a mark for minus 6, a mark for f of x is less than or equals 10, and then here you have to have 6a equals 24 and then say so a equals 4, and it looks like we've got part D as well. So hence solve, when does f of x equal g of x? So f of x was 10 minus x squared, and g of x, now we know that x is 4, g of x is going to be x plus 8 times by x plus 3. So we just need to solve this equation. So 10 minus x squared equals x squared plus 11x plus 24. So if we get everything on one side, we've got 2x squared plus 11x plus 14. Yep, so we've added x squared and taken away that. So we can't divide everything by 2, unfortunately, but hopefully this will factorise. So we've got to have a 2x and an x, and because both of these are positive, I reckon both of these will be positive. So this one's going to be times by 2x, and this one's going to be times by x, and they've got to add up to 14. So I reckon, sorry, they've got to add up to 11 in total. We're going to have a 7 here and a 2 here. So then we'll get 2x squared plus 4x plus 7x plus 14. So when we solve it, x can either equal minus 7 over 2 or minus 2. So on the mark scheme, you get a mark for kind of setting them equal to each other, a mark for getting to this quadratic, a mark for kind of factorising it with a 2x and an x, and then as long as your CD here multiplied to give 14, you'll get 1 mark. Or you can do quadratic formula, and then a mark for the final answers of minus, we're 7 over 2, minus 3.5, both are fine. Good. Right, so on to question 6. The nth term of a sequence is 2n squared plus 7 over 3n squared minus 2. Work out the 7th term, give your answer as a fraction in its simplest form. So if we're finding the 7th term, we just literally need to sub in 7. So 2 times 7 squared plus 7 over 3 times 7 squared minus 2. So that's going to be 2 times 49, 2 times 49 plus 7, so 105. And on the bottom, 3 times 49 minus 2, which is 147, 145. So it looks like those can both divide by 5, so this would be 21 over 29, I want to say. Yeah, good. So the answer would be 21 over 29, I hope. Right, show that the limiting value of this nth term is 2/3. So I think that it doesn't just say state the limiting value. We need to somehow show this. So, I mean, if we look at it, we can see as n becomes very large, the only significant terms are going to be 2n squared over 3n squared. So the n squareds would cancel out and we just have 2/3. But it's important we kind of note this properly in the exam. So there's our 21 over 29. So there's a couple of ways of doing it. You can either divide each term in the fraction by n squared. So 2n squared becomes 2, 3n squared becomes 3, 7 becomes 7 over n squared, 2 becomes 2 over n squared. And then as n tends to infinity, both of these will tend to 0. So these would disappear and you'd just be left with 2/3. So the other method is kind of a bit more like our hand wavy explanation, where we say as n tends to infinity, 2n squared plus 7 tends to 2n squared, because we're saying, well, the 7 becomes insignificant. And similarly for the bottom one, so the limiting value is just going to be 2n squared over 3n squared, which is 2/3. So just be careful with a show that it's kind of, you have to do more than just it says quote what the limiting value is, because they've already told it as in the question anyway. Right, question 7. ABCD is a cyclic quadrilateral. Work out the values of x and y. So really they're testing your circle theorems. So hopefully you know the opposite angles in a cyclic quadrilateral add up to 180. So we know 2x plus y plus 20 equals 180. And also x plus 2y plus y plus 40 equals 180. So you've got a couple of options here of how you approach this. So you could maybe tidy up both equations and then solve them as simultaneous equations to find x and y. So on the left hand side we've got 2x plus y equals 160, and on the right x plus 3y equals, so we've got to take away the 40, 140. So now it depends how you want to do it. You could do it by elimination or substitution. So I'd probably recommend, if I make this a bit tidier, but it's not going to let me. So I will continue above. So what I'm going to do is double this second equation, so it's going to become 2x plus 6y equals 280. And the other one I'm just going to write underneath was 2x plus y equals 160. Right, so now we can take away the bottom equation from the top. So 6y minus y is 5y. 280 minus 160 is 120. So y is going to be 24. And then we just need to sub that into either of them. So I'm going to sub it into this one. So we get 2x plus 24 is 160. So 2x is 154. So x will be 77. I hope and pray. Right, so looking at solutions, what do we have? 24 and 77. So you get a mark for any one of the equations, and then a mark for, is that for tidying it up? Well, a mark for another one of those equations, a mark for equating coefficients and elimination of x or y. So essentially a mark for starting to solve these algebraically. And then we should have got 68 and 24, so I've done something wrong there. So our y was right. What have I done wrong? So I just can't take away, that's why. So we should have got 2x plus 134, which would have been 68. Okay, remember it's a non-calculator exam, and it is easy to make little slip-ups, as you can see. Right, AA, factorise fully. So the fully is the important part here. So we can't just take out a 3, because actually we can do more with this. So if we take out a 3, we'll have x squared minus 4. And then we've got to think, well, can we factorise this? And hopefully you can see that's the difference of two squares. So we get 3 lots of x minus 2, x plus 2. Right, so moving on to 8b, this is quite a difficult factorisation. So hopefully you can spot that it's going to have to be double brackets with some x's and some y's in both, because we've got no constants. Right, so first of all we can see to get this 5x squared, this must have to be a 5x here and this must have to be an x here, or the other way around. And then we've got to think, well, what would multiply out to give us a plus xy? So hopefully you spot both of these numbers are going to have to multiply together to give minus 12. So we've got some options. We could have one of these has got to be minus, but 1 and 12, 2 and 6, or 3 and 4, or the other way around. So let's try and think which way around I have to give us a plus 4xy, but also a minus 12. So we could put any of these here, and we'd still get a minus 12 y squared. But we've got to try and think, well, we want to also have a plus 4xy. So if we think this term's going to be times by this one, and this term's going to be times by this one, and let's try out these different combinations and see which are going to give us a 4xy. So we could put a 2 here, and then we'd have 10xy. And then if we put a minus 6 here, that would give us minus 6xy. So if we put a plus 2 here, a minus 6 here. So if we imagine timesing out, we've got 5x squared, which is correct, plus 10xy minus 6xy, so that would give us our plus 4xy minus 12y squared. So that would all work out. So it takes quite a lot of kind of logic. So these ones, if you've got an x squared, an xy, and a y squared, you know it's going to be some x's, some y's, some x's, some y's, and then you need to use a bit of logical deduction to work out what it would be. So you do get, you'll get 1 mark for having 5x plus some number of y's times by x plus some number of y's. You'll get a mark for kind of having a 6 and a 2 there with any plus or minuses, and a final mark for having minus and a plus. Right. So question 9 is one of these coordinate geometry, the ratio-y type questions. So ABC is a straight line, so A is minus 9, 18, C is 16, 3. BC is 20% of AC. So in other words, going from B to C is a fifth of the whole length, and they want us to work out the coordinates of B. So if you think what's going on, to get from A to C, we've had to go along from minus 9 to 16, so that's 25, and we've had to go down from 18 to 3, so we've had to go down by 15. So if we're going to B, that means we're going 80% of the way along. You could have done this the opposite way around and gone 20% all the way from B to C. So if we think about the x coordinates, we're going 80% along this 25. So I reckon that's going to be 20. And then in our y coordinates, we're going down 80% of 15, which is 12. So we need to go along 20 from minus 9, so minus 9 plus 20 is 11, and down 12 from 18. 18 minus 12 would be 6, so you get 11, 6. So on the mark scheme, you get marks for kind of plus or minus 25 or plus or minus 15 seen. Mark for using 80% or 20% in a correct calculation, and an answer mark each for 11 and 6. Right, question 10, rationalise the denominator. So hopefully you know this means you've got to times the top and the bottom by the conjugate of 3 minus 5. So that means you're timesing it by 3 plus root 5. So we'll have 24 plus 8 root 5 over, now you could expand all this out, but it's a bit easier to think of it as difference of 2 squares. So 3 squared is 9, take away root 5 squared, which is 5, so that's 4. So 24 divided by 4 is 6, 8 root 5 divided by 4 is 2 root 5. Okay, so a mark for mark for timesing by that, a mark for your numerator or the denominator, and a mark for 6 plus 2 root 5. Right, here is triangle ABC. Show that angle B is 60 degrees, so this angle here. So hopefully you can spot, we've got 3 sides and we want an angle, so we're going to be using the cosine rule. So cos, it's confusing because it's B, so let's just try and write out the cos rule with A as we remember, and actually it's probably in our formula sheet at the start. So we do get it, so cos A is B squared plus C squared. In fact, I'm going to write it in because this is the one I can't remember. b squared plus c squared minus a squared over 2bc. And they're just trying to upset us by making it cos b. Right. So you can either replace it, or you can just think, well, I'm just going to call this cos b, and then I'm just going to remember this is going to be my b squared. So that's going to be minus root 14 squared. So root 14 squared is 14. So our b and c are actually just going to be our other two sides. So this is going to be b squared. So let's say that's this side. So root 2 squared is 2, plus this side squared. So 3 root 2 squared is 9 times 2, which is 18, all over 2bc. So 2 times 3 root 2 times root 2. So however you've done it, you should have in this order basically. So the top is going to be 20 minus 14, which is 6. The bottom is going to be 2 times 3, which is 6, times by root 2 times root 2. So this is 2 as well. So this becomes 2 times 3 times 2, which is 12. So you get cos b equals a half. And then hopefully you know your triangles, which should help you say, well then, if cos b is a half, that implies b is 60 degrees. And you can quote that. So let's look at the mark scheme. So you need something to say cos b equals, you don't even need the cos b, so something where you're working this out. You get 1 mark for getting to this and you're allowed an error, a final mark for getting to a half and saying that b is 60 degrees. So you can just quote it, you don't need to show the triangle or anything like that. Right, 11b, hence work out the area of triangle ABC. So now we know this is 60 degrees. We can do half AB sine C. So if remember, this is going to be two sides plus the included angle, and it doesn't match up to these here. So that's why it's worth knowing what the formula means. So a half times 3 root 2 times root 2 times by sine 60. So you need to know, using your trig triangles, which look like this, so that's 60, that's 30, this is 2, this is 1, this is root 3, so hopefully you can draw that out relatively quickly, that sine 60 is going to be opposite over hypotenuse, so root 3 over 2. So we've got a half times by 3 times root 2 times root 2 is 6, times by root 3 over 2. So we've got 6 root 3 over 4, which is 3 root 3 over 2 as a final answer. So you can get asked trig questions outside of a calculator paper. So you need something, if anywhere they see sine 60 is root 3 over 2, you'll get a mark for this method and a mark for a final answer. Right, question 12. The line x equals minus 9 is a tangent to the circle with centre 820. Show that the radius of the circle is 17. So because we know this is vertical, and this is because this is a radius and this is a tangent, that's going to be a horizontal line. We know that's going to be the point minus 920. So if we think about the distance of this, we don't need to use our distance formula because we can just see, well, the x coordinates go from minus 9 to 8. So 8 minus minus 9 is 17. Okay, good. 12b says the circle intersects the y-axis at A and B. Show that the length of AB is 30. So we essentially need to work out what are the coordinates of A, what are the coordinates of B, and then it looks like it's not going to be that bad to find the length. So hopefully you can see we know the radius is 17, we know the centre, which means we've got enough information to write down the what's it called? The equation of the circle. So just scroll down, I've forgotten that. So 820. So we know it's going to be x minus 8 squared plus y minus 20 squared, and that's got to equal 17 squared. So if we're working out where it crosses the y-axis, that means we're going to make x equals 0. So this will become minus 8 squared plus y minus 20 squared, and that's going to equal 17 squared. I'm not sure. So you would, given this a non-calculator exam, you cannot, like me, put this in your calculator. You would actually have to do the kind of long multiplication, however you want to work it out. So that would be 289. So now this becomes 64 plus y minus 20 squared equals 289. So it would be, I reckon, difficult to expand all this out and then solve it. But given it's already in completed square form, we can say y minus 20 squared is, so 289 minus 64 is 225. So it ends up as a nice square number. So square rooting each side, y minus 20 will be plus or minus 15. So y can equal either y minus 20 equals 15, in which case y equals 35, or y minus 20 equals minus 15, in which case y equals 5. So we can see the coordinates of A and B must be 0, 5 and 0, 35, depending which is higher. So the distance between them will be 30. So the final answer is 30. Okay, so a mark for right-angled triangle form with 8 and 17. Okay, this isn't the method I use. So the method we just did was this. So finding the equation of the circle, setting x to 0, and then solving it. So the way they've done it is done some kind of right-angled triangle on the diagram with lengths 8 and 17, and then shown that one of the lengths of this, so the length to get to the y-axis, will be 15, and then use that's the midpoint of AB to work out how to get from A to B. I prefer my way, but some people are more geometrically minded. Right, a curve has equation y equals x cubed minus 3x squared plus 5. Show that the curve has a minimum point when x equals 2. So if we're looking for minimum points, that means we need to find the derivative and set it equal to 0. So that will be 3x squared minus 6x, and the 5 disappears. So if we're looking for stationary points, we need to set this equal to 0. So we can factorise out 3x, and we get x minus 2. So either 3x equals 0, in which case x equals 0, or x equals 2. So we know we've got stationary points here and here. We're not interested in this one, we're only interested in the 2. So it's up to you now how you decide whether this is a minimum or a maximum. You can either look at the gradient either side, so maybe sub in 1 and 3 into this, or if you find the second derivative, so that would be 6x minus 6. If we sub 2 into that, we'll get 6 times 2 minus 6, which is 6. Now as this is positive, so as this is greater than 0, we can say therefore x equals 2 is a minimum. Is a minimum point. If it was negative, it means it's a maximum. If it equals 0, you have to investigate further. So you have to do the kind of subbing in either side, because it could be any of the 3. So looking at the mark scheme, so you get a mark for the derivative when x equals 2. Yeah, so instead of solving it, they've just subbed in 2 to show it 0, and then work out dy by dx either side. And you see our alternative method here is using the second derivative. Right. 13b, show the tangent at the minimum point meets the curve when x equals minus 1. So the first thing we need to do here is actually find the tangent at the minimum point. So if it's a tangent at a minimum point, we know it's going to be horizontal. So we know it's going to be y equals something, because we know its gradient is 0. So we're not going to have to bother with y because that makes plus c. So when x equals 2, we're going to have to find the y coordinate. So if we sub in 2, we'll be doing 2 cubed minus 3 times 2 squared plus 5. So that's 8 minus 12 plus 5, so that's minus 4 plus 5 is 1. So we know this is the coordinate 2, 1. So this line must be y equals 2. So we know what the tangent is there. Remember, this was only quite easy because we knew it was horizontal. If it was anything else, we'd have to like find the gradient and sub in a point to work out the kind of y equals mx plus c. But the final question says, show the tangent at the minimum point meets the curve again when x equals minus 1. So if you imagine what's going on, we're saying when y equals 1, this has got to, this will, when we solve that equation, that's going to meet the curve again at x equals minus 1. So let me draw a diagram to say what I mean. So here's our point 2, 1. Here's our tangent. So we're trying to show this tangent's going to meet this curve when x equals minus 1. Right, good. So we know then that the equation of the curve, which was y equals x cubed minus 3x squared plus 5. We want to sub in y equals 1. So we want to, in other words, we're kind of subbing in our tangent. And we could solve this cubic equation, but that would be quite difficult because it's just to show that if we sub in x equals minus 1, and hopefully we get an answer of 1, so we're doing minus 1 cubed minus 3 times minus 1 squared plus 5. So that is minus 1 cubed is minus 1, minus 3 plus 5, so that's minus 4 plus 5, which equals 1. So we can say our tangent does hit the curve then. So you get a mark for subbing x equals 2 in the equation of the curve to find the corresponding y value, which is what we did to get our y equals 1. And then subbing x equals minus 1 into the equation of the curve to verify that y equals 1. Right, so question 14 looks like there's more cubics. So it says x minus a is a factor of this cubic. Show that a equals 2. So you need to know by the factor theorem, if x minus a is a factor, that means f of a equals 0. So in other words, when we sub in a, the answer is 0. So let's sub in a. So we've got a cubed plus 2a times a squared minus a squared times a minus 16 equals 0. So we've got a cubed plus 2a cubed minus a cubed plus 2a cubed minus a cubed minus 16 equals 0. So in other words, 2a cubed minus 16 equals 0. So 2a cubed equals 16. So a cubed is 8. So a must equal 2. Right, then it says solve x cubed plus 4x squared minus 4x minus 16. Now I'm hoping that is the same cubic as above with a equaling 2. So let's try it. So x cubed plus 2ax squared, so that is going to be plus 4x squared, minus a squared x, that is going to be minus 4x, minus 16 equals 0. Right, so given that we know a equals 2, that means we know x minus 2 is a factor, so we can factorise out x minus 2. Okay, so let's give myself a bit more space. So we know then this cubic must equal x minus 2 times by some quadratic, so some lot of x squared plus or minus some lot of x's plus or minus some number equals 0. So I'm going to use my grid method. So I'm saying then that x minus 2 times by some x squared, some x's and some number. So by my grid method, this box must contain that cubic. So x cubed must go here, and that must mean minus 2x squared goes there. So the only other place we're going to get an x squared is from here, and we need to end up with plus 4x squared. So this must contain 6x squared, which must mean this must be a 6 that goes here. So down here must be minus 12x squared. We've got to end up with minus 4x, so there's going to have to be an 8x here. So this must have to be plus 8. And then just to double check, 8 times minus 2 is minus 16. So when we factorise it, we should get 1x squared plus 6x plus 8. And then we can see, can we solve this, can we factorise this cubic? So we need two numbers at times to give 8 and add up to give 6, so that would work. We could have x plus 2 and x plus 4. So there's lots of different ways of doing it. You pick the one you like the most. So you get x equals minus 4, minus 2, or 2. Right, so for part A, it looks like you get a method mark for subbing in A and a method mark for arriving at A equals 2. Right, there's loads of different methods. Essentially, you've got to factorise out x minus 2. That gets you a mark for recognising that. A mark for x squared plus 6x plus 8. A mark for factorising x squared plus 6x plus 8. And a mark for the final answers 2, minus 2 and minus 4. Right, so question 15, we've got sine theta minus sine cube theta over cos cube theta. We need to prove that's identically equal to tan theta. Right, I think this is a really difficult trig question. It makes sense, it's near the end of the paper. So I would look at the top and think, well, can we factorise this? So we can factorise out sine theta, and we'd have 1 minus sine squared theta. Whoops, that should be a sine theta times by 1 minus sine squared theta over cos cubed theta. Now, 1 minus sine squared theta, because we know sine squared theta plus cos squared theta equals 1, that must be equal to cos squared theta. So this would equal sine theta times by cos squared theta over cos cubed theta. Now we can see that these cos squareds will cancel with 2 of these from the cos cubed theta. So this will cancel down to sine theta over cos theta, which we know is the definition of tan theta. So if we look at what we've done, I think you need to spot, because this is factorisable, factorise that and then see what happens. And you need to be able to recognise things like 1 minus sine squared theta, 1 minus cos squared theta can be subbed in with these. And then once you sub that in, the fraction cancels down. So you will get a mark for spotting things. So let's have a look. They've got a couple of methods. So the first one, they've done what we've done. So you get a mark for factorising, a mark for subbing in cos squared theta, and a mark for cancelling down to arrive at tan theta. This method's kind of similar, but they've factorised the top and the bottom, it looks like. So they've made this cos theta times cos squared theta and replace it with 1 minus sine squared, and then cancelled out both the 1 minus sine squared. That's a bit trickier to spot, I think. Right, 16. So last question. So 2x squared minus 2bx plus 7a equals this. Work out 2 possible pairs of values for a and b. So looking at this, I would expand out the right hand side and see if you can equate coefficients. So we've got 2x squared minus 2bx plus 7a. And now let's expand out the right. So we've got 2 lots of x squared minus 2ax plus a squared plus 3. So again, we've got 2x squared minus 4ax plus 2a squared plus 3. So now let's think about the number of x's, number of x squares, the number of x's and the constants we've got on each side. So we can see we've got 2x squared on this side, 2x squared on this side. That doesn't really help us much. We can see we've got minus 2bx on the left and minus 4ax on the right. And the constants we've got 7a on the left and 2a squared plus 3 on the right. So they're the things that don't involve any x's. So we know two things now. We know minus 2b equals minus 4a, and we know 7a equals 2a squared plus 3. So if we solve this, because this equation only involves a's, we'll get 5a squared. Sorry, I'm talking rubbish. So this is now a quadratic. So we'll have 0 equals 2a squared, sorry for my horrible 2, minus 7a plus 3. So we could end up with two solutions to this. So we're going to have 2a and a. And then we know this has got to be a 1 and a 3 or a minus 1 and a minus 3. Now I reckon it's going to be a minus because we need a minus there. So if we put a minus 3 here and a minus 1 here, we'll have 2a squared minus 6a minus 1a plus 3. So either a equals a half or 3. This is why it says two possible pairs of values. So now we need to sub these into this equation. So let's simplify it a bit and divide both sides by minus 2. So we've got b equals 2a. So if a is a half, b will be 1. If a is 3, b will be 6. So those are our two solutions. A is a half and b is 1, or a is 3 and b is 6. So you get, so this is the first, have they done it our way? Yep, what have they? So just, you can see there's loads of different ways here. So this is the one where they're equating coefficients. So you can see them solving to get a. So that gets you 4 marks to arrive at those a values. So 1 for expanding out, 3 for solving, a mark for subbing into the other equation, and a mark for the final answers. Right, and that's the end of the paper. I hope you found that useful, and let me know if you have any other requests for more papers to go through. Thanks.